Okay, so next up we have temperature. Temperature is another way to change an equilibrium. So I'm going to kind of cheat here and make up something. I don't know if this is true or not. But one way to talk about energy with chemical reactions is we add, both of these take energy, right? This takes energy in, this releases energy. That's something you should learn with bond energies. If we write like plus heat energy on this side of the reaction, that means that after you add up and take away all the energy change in this system, there's a net release of energy. What that means is this side of the reaction is exothermic, producing heat. But it also, remember, with equilibrium, we have another reaction going back this way. That reaction is going to be exactly opposite, and it's going to be endothermic, to the same amount that this side is exothermic, right? So this side produces heat. These two, when they come together, they need heat to go back this way, okay? And so we can use this to change the equilibrium, right? So once these have reached equilibrium, if we want to shift that equilibrium one direction or the other, we can add or take away heat, and let's see how that's going to affect it. So let's start by adding some heat. Let's put this beaker into like a hot plate or a Bunsen burner and warm it up. So we're adding lots of heat energy. And so remember from the other video, we shouldn't just try and memorize, okay, if we add heat on this side, it's going to push it this way. That is going to be the answer, but we want to understand why. We want to not memorize, but think critically here. This reaction happens on its own, doesn't really need a lot of heat. But this reaction, right, it needs this heat energy to get these to bump into each other and turn into this. So this reaction really benefits from having heat around, which means this reaction is going to happen a lot better and a lot faster if we add heat to it, right? So this endothermic reaction is favored when you add a bunch of heat because it needs that heat energy to its reaction. So when we add heat, these guys are going to start going and reacting and creating this stuff much, much faster. Whereas these guys, not so much. Like, I mean, obviously heat will increase the speed of any reaction, but these guys are not an endothermic reaction. They don't really need a ton of heat to keep going this way. So when we add heat, we're really favoring this side of the reaction right here, okay? And so what ends up happening is that we're shifting the equilibrium this way. So what does that do to our chemicals? Well, now these guys keep reacting all the time. They're reacting a lot faster. So the amount of them is going to go down. And whenever they react and their concentration goes down, they're turning into and creating these chemicals over here, right? So the heat has shifted our equilibrium to the left, right? It's favoring the product reaction, shifting it to the left. That reduces our products and increases our reactants, right? And then obviously the opposite is going to be the same thing, right? If we, instead of taking heat, let's say we cool this reaction down. So we just take away heat, put this on an ice bath. Well, remember, these chemicals need this heat to react, right? These chemicals, not so much, right? So if these chemicals need this heat to react and they don't have this heat anymore, we're reducing it, cooling it off, taking away that heat, these guys are going to slow way down. These guys, not so much, right? So we're going to have this is still going full speed, but this one is slowing way down and not coming over here as much. And so it's going to shift our reaction to this side now, right? So when we take away that heat that's needed for our endothermic reaction is going to be greatly affected. And so how does that affect our concentrations? Well, these guys are reacting over here, so they're going away, and they're producing these guys. These guys are building up, right? As we get more and more of them, they don't have the heat to react and go back this way, and so they're going to start building up, okay? So we're going to lower these concentrations here. We're going to increase these concentrations here, okay? And this is all true. If we put heat on this side, right, if this was the endothermic reaction and this was the exothermic reaction, all of this would still work. It just would be switched directions, okay? And that's pretty much it, though, for heat. You can almost treat it like it's concentration, right? Just like when we decreased our water concentration, it pulled the reaction this way. Same thing here. Look, our heat, when we decrease it, also pulls the reaction this way. So I don't want you to memorize it that way. I would like you to understand that it's pulling it this way because this can't react anymore. That's the logical way to think about it. But notice that it works very similar to concentration.